Hello, I'm Dima Zaitsev, and we continue our lessons in embedded system design. Today we will consider Sleptsov net-based reliable embedded system design on FPGA. To find additional information on the subject and maybe other topics as well, you can open my website. With respect to our today's lesson, we will follow our recently published conference paper, Sleptsov net-based reliable embedded system design, published with my master students from China. So the process is specified maybe closer to the bottom of the paper for FPGA. Here we are using graphical editor ND of system TINA as an integrator of tools. We produce Sleptsov net specification and pin map for future, and we are using our tool compiler of Sleptsov net into Verilog code. The resulting Verilog code is uploaded to Gowin FPGA Designer and then to FPGA. As an example, we use vending machine, and its picture is within the paper. There is a slot for coins of one type and two buttons, sell chocolate button and the coin return button. We sell chocolate bars of two types, milk chocolate for 2 coins and dark chocolate for 3 coins. We have a pocket of returned coins and a pocket for chocolate bars. Sleptsov net specification, graphical specification of this vending machine is represented within the paper and described within the paper. To continue with this specification, we open it within graphical editor TINA. So here you can see this model. Input places are mapped to input signals, to buttons of our prototype, and the output places are mapped to the output signals, to LEDs of our prototype. Let us consider how it works. So the prototype is the same as for the previous lesson. So we have first button that corresponds to coins, second button for chocolate bar selling, and the final button for money back. And our connections with pins you can maybe explain using this picture of pins for FPGA Tang Nano of Sipeed company that is based on Gowin chip. So let us return to the model and consider how it works. 1 coin, 2 coins, 3 coins, 4 coins. Fourth coin is returned because we are not bank, we do not keep money. And if we press a button, the dark chocolate is sold because we will have 3 coins inside. 1, 2, 2 coins inside. And now milk chocolate is sold. 1 coin and 1 coin back, no more coins back. 1, 2 coins, 1, 2 coins back, no more coins back, and so on. You can create the prototype and test it. We will follow our tool chain. So having this specification, we can prove correctness of embedded system using tools of TINA toolset, And I would like to mention that Tina was a winner of model checking contest, so it can analyze very big nets in a reasonable time. To create Sleptsov net specification, we are using our plugin. We choose H file, and the Sleptsov net specification in the form of matrices, vector, and additional comments is produced. And later on, maybe I will mention the GitHub, my GitHub, from where you can download Sleptsov net programming tools. And after we created this file, we compile it into the corresponding Verilog code. For this purpose, we are using GitHub of Zhang. You can find the corresponding reference within the paper. And as for the plugin, it is situated on my GitHub together with other SNC Sleptsov net computing tools. So we copied the obtained H file. H file produced the result of plugin work. We copy it to the directory of the compiler, and we open this code within compiler from C language. Here we are using DevC compiler. We just insert the file name as included file. We compile code and then we run it. At the result, Verilog code corresponding to the process of running Sleptsov net is created. Here we are having brief header of the corresponding module, which has clock as input signal, and one result is indicated using internal LED. So we take this code into Gowin FPGA Designer and edit this code to provide connection with input and output signals, and also we are doing debouncing for buttons. And when we have Sleptsov net running, we need to implement this signal mapping as well. So now we come to the Gowin FPGA Designer, and here we open design and open Verilog file. Within the Verilog file, which you can download from my GitHub, I specified corrections we are doing on the compiled Verilog module, and I specified them like 1, 2, 3, 4, 5, 6 corrections using this sharp symbol and the corresponding number. First, we insert the module header. We replace the module header with the header that contains input and output signals as it was described in our model. So these 3 input signals and 3 output signals. The second correction is here. We add debouncing code and clock division code. And then within the module we have modification number 3. We specify variables which correspond to slow signals. So after debouncing we call them slow, and we specify instantiation of debouncing module, which is implemented 3 times for each input signal, and we specify slow clock via instantiation of the clock division. We are using this slow clock within always block, so it is correction number 4, and the correction number 5 is mapping mapping of input signals into input places of PetriNet, these 3 assignments, and to comment on them I open our H file. Here we can see that coin is mapped into place number 4. So when we return, we can see here P4 equals slow coin. And also we add code which switches off LEDs, which reset the output signals when some button is pressed. And finally, we have modification with respect to the mapping of output signals. So we assign the value of the corresponding output place of Sleptsov net to the output signal. For this purpose, we also use this command. So, for instance, returned coin is within the place number 7, so we come here and we have this R coin equal to P7. Similar to the tools for reliable Sleptsov net-based design for microcontrollers, we plan to insert this code in automatical way. Maybe some talented students will take this task and implement it. Now we come to the actions, processes of this Verilog designer. We run synthesis, we run placing, and finally, using programmer, we upload code onto FPGA. I would like to return to advantages of our approaches and emphasize on them. Maybe now we consider this model within our paper, because it is an open model which we are using as a program for control, and we can unite this model with models of plant, and we can verify the corresponding integrated model using tools of TINA. So in this way we provide reliability, we prove correctness of work of our embedded system, and it is done similar for microcontrollers and FPGA, and only on the final stage we branch our tool chains. So if you have additional questions, I believe that this paper will resolve them. And if you'd like to follow the lesson and create the corresponding prototype, you can download code from my GitHub and GitHub of my students and run it. If you have more questions, I invite you to visit my website and maybe learn that we apply Sleptsov net computing not only for reliable embedded system design, we apply it in supercomputer and HPC domain as well. Thank you.